Well, hey there, everybody. It's your boy, Mr. Perry. It's time to get into Unit 3, Lessons 4 and 5. You're getting a little 2-for-1 yet again for this unit, so let's get into it. All right, so we're going to start with the problem that is illustrated here by this image, by this algorithm. So I'm going to encourage you to pause the video and read through this program code and try to figure out what the problem is. I'll give you a second to do that. And at this point, I'm assuming you went ahead and paused the video and you worked your way through it. So let's go ahead and see what's going on. So obviously, this is an algorithm that is intended to tell somebody how old they are based on the variable age. But there is fault in the design, and that's because when you go ahead and run this, as it's currently set up, we're getting all three of them. If int age is 25, then it is older than 18, so it's going to print this. And then it's also greater than 12, so it's going to print this. And then it's also greater than 5, so it's going to print this. So whoever wrote this algorithm was attempting to write something that would print only, you're either this, or this. But instead, because of these problematic if statements, we're getting all three. So if we want to avoid having this kind of an issue where we're just stacking an if statements on top of if statements, then we need to use what's called multi-way selection, which hopefully you're familiar with already. And multi-way selection is when we have if, else if, and then else. And we can have as many else ifs as we want to. So we can have one else if, or we can have 5 or 10 or 20 else ifs if we need to. And the way it works is it'll check if this condition is true. And if it does, it's going to perform this action and then skip everything else. And then if it doesn't pass this condition, then it's going to check this one, and it's going to see, well, will this condition become true? And if it does, it will perform everything that's here and skip everything else that's down here. And if it doesn't pass condition 1 and if it doesn't pass condition 2, then you are guaranteed to get the output from whatever is in the else category. And take note that if has its own set of curly braces, else if has its own set of curly braces, and then the else section also has its own set of curly braces. So the benefit of multi-way selection is it guarantees that only one outcome will occur. As soon as one of the conditions evaluates to true, the rest of the conditions are automatically skipped. So that's the big benefit of multi-way selection, is it just guarantees that you're only going to get one outcome instead of potentially getting multiple. So if we went to our back to our original algorithm, we could fix it, and we could say, well, if age is greater than 18, you are a legal adult. Else, if age is greater than 12, you are a teenager. Else, if age is greater than 5, you're old enough for kindergarten. Else, you're too young for school. So now we've got something that is guaranteed to give you only one outcome instead of all of the outcomes like we had before. So with if statements, if we're only using if statements, we have to be a lot more careful because any one of them might run depending on whether the condition is met. So again, this can cause problems if the algorithm is not properly put together. And then you also have learned if else statements, which guarantees only one of two outcomes will happen. So that's what we had in our previous lesson. So if age is greater than 5, it's going to print you're old enough for kindergarten and skip the else automatically. But if age is not greater than 5, then you are automatically bumped into the else category. With multi-way selection, you have a lot more flexibility, but only one of the conditions will be met. So it guarantees only one outcome. So if age is greater than 18, it prints you are a legal adult. Everything else just automatically gets skipped. The compiler doesn't even look at it. If it doesn't pass the first check but passes the second condition, it prints you are a teenager and then automatically skips everything else down here. If it doesn't pass the first two checks, but it does pass, the check age is greater than 5, it's going to print you're old enough for kindergarten and then skip what's in the else. And then, like we said already, if it doesn't pass any of these three conditions, then we are automatically bumped down here into the else situation, and we get the you are too young for school. All right, so that is multi-way selection in a nutshell. Pretty straightforward, but we get a little bit more complicated when we start talking about compound selection statements. So we're going to look at multi-selection with compound statements. And with compound selection statements, this is when we're testing two or more conditions using ands, or as we'll see, there's also or gates that we can work with. So for ands, we've got if condition 1 and condition 2, and then we've got our set of curly braces, and then it's perform this action. So with conditionals that use and, both conditions must evaluate to true for the action to be performed. So whatever condition 1 is, that's got to be true, and whatever condition 2 is, that also has to be true. So if we were doing a program to determine whether or not somebody can vote, here we've got int age is 19, Boolean is registered is equal to true. So then it's checking if age is greater than 18 and is registered equals true. If both of those are met, then we will print you can vote today. So that would be the outcome on that one. If these are not both true, then we can also check else if age is greater than 18 and is registered is equal to false. Then we would probably tell that person you must register to vote. And so there you go. That's how that would work. And of course, if it doesn't pass both of those, we would go into the else, which says you're not old enough to vote. And there you have it. We also can use what are called ors. To use an or, we have to use the up and down lines. Now, these are found on your keyboard above the enter key. If you hit, it's the same as the backslash key. So if you hit shift and then that key, you're going to get that up and down line. Now, if you put two of them back to back, then that means or in Java. So one thing or another thing. So if we go down here, we would say if age is less than 18 or is registered is equal to false, then we would say you cannot vote today, because that would be, the logical condition to put together on that one. If someone is less than if someone is not older, if someone is not at least 18 years old, and or if someone is not registered, then they would not be able to vote. So again, just that general syntax, if condition 1 or condition 2, and then we have our curly braces, and then we would say, perform whatever action we're asking it to do. With conditionals that use or, only one of the conditions must evaluate to true for the action to be performed. So if condition 1 is true, then it's going to happen. If condition 1 is false, but condition 2 is true, then this is going to happen. And of course, if they're both true, this is going to happen as well. So now it's time to introduce you to truth tables. If you have never created a truth table before, this is where we start doing them in Unit 3. Now, truth tables start off easy enough. They're basically truth tables. They are a way to test all of the potential outcomes of a compound conditional statement. So if we are looking at two conditions, condition A and condition B, and we want to see what is going to be the outcome of A and B, one of the ways we could test that is with a truth table. Now, to create a truth table, you do a column for your first condition, and then you label it as true, false, true, false. Then you do a column for your second condition, and this time you go true, true, false, false. Now, what this does is this gives you all of the combinations, all of the potential combinations of true, false outcomes for these conditions. So A and B can both be true, which means A and B would be true. A could be false, but B could be true, which means A and B would be false. A could be true and B could be false, which means A and B is going to be false. And of course, if A is false and B is false, then they're going to both be false. To make one for an or statement, then we've got A true, false, just like we did over here. And then we've got B, true, true, false, false, just like we did over here. That gives us all of our combinations. And now true or true is going to give you a outcome of true when you're looking at a or B situation. False or true is going to give you a true outcome when we're looking at or. True or false is going to give you true, and then false or false is going to be false. So that's how you come up with truth tables for two conditions. And truth tables are just something you're going to need to kind of memorize through practice. They're not too hard. You just need to remember that pattern of true, false for column A, and then true, true, false for column B. But we are going to get more complicated with our truth tables. So again, just make sure you understand how these are set up before moving on. Now, there's one thing that's important to note here, that A and B is similar to multiplication. Since, 1 times 1 is 1, just like true and true is true. But then 0 times 1 is 0, and that's similar to false and true is false, true and false is false. And then, of course, 0 times 0 is also 0, and false is also going to be 0. So associate an AND condition with multiplication. And then over here, an OR condition is similar to addition. And that's because 0 plus 1 equals 1. So you can think of that as false or true is going to give you true. And then true or false is going to give you true. That's kind of like 0 plus 1 is equal to 1, or 1 plus 0 is equal to 1. And then also false plus false, or false or false is going to give you false. That's also similar to 0 plus 0 equals 0. And again, it's useful to associate an AND statement with multiplication and an OR statement with addition. You'll see why in just a second. What we need to do is we need to talk about precedence. And let's say we had A is equal to 1, B is equal to 2, and C is equal to 3. Go ahead and pause the video and work your way through these Boolean statements that you see down here. These are compound Boolean statements. All of them are going to evaluate to either true or false. And again, take a second and plug in these values and see if you can figure out what they are going to evaluate to. The first two are probably going to be easy, but then when you get to the second two, again, things are going to get a little bit more difficult. So go ahead and pause the video, see if you can figure this one out. I'm going to assume that you have paused the video at this point. So let's go ahead and start working through them. So let's look at the first two. So these really aren't all that hard. Is 1 less than or equal to 2 true? So we know this condition would evaluate to true. Is 2 less than 3? That is also going to be true. So we're going to end up with true and true, which we know is going to evaluate to true. So this entire compound Boolean statement evaluates to true. Down here, is it true that 2 is less than 1? No, it's not. This is false. However, it is true that 2 is less than 3. And since this is an OR statement, then this side would be true. False or true, we know is going to evaluate to true. So this would also evaluate to true. So we've taken care of this one and we've taken care of this one. But now we need to look at this one down here because there's a little bit more going on. We've got a condition A or condition B and condition C. Now, when we talk about precedence here, and conditions evaluate before or conditions, just like multiplication comes before addition. Remember I said think of and kind of like multiplication and think of or kind of like addition. And if we go back to PEMDAS, we know that multiplication always gets done before addition. So what that means is we have to evaluate, is B greater than 0 and is B greater than 1? Well, B is 2, so it's true that B is greater than 0 and it's true that 2 is greater than 1. So this and this will evaluate to true. So now you just need to figure out, is 0 greater than b, which it's not. However, this is an or statement. So because this is false really doesn't matter. We already know this is true. That means the entire thing is going to become true. All right, now that we've done that one, again, pause the video and see if you can do the next one. I'll assume you've paused the video and you've tried it out. So with this one, the only thing that's different is we have multiple and statements. We also have multiple or statements. So evaluation is always performed from left to right. So that means we have to evaluate this one first, because this is our first and situation. So we have to check, is B greater than 0, which it is, and is C greater than B, which it is. So that means this first one right here is B greater than 0 and is C greater than B. That entire thing evaluates to true. So that whole part becomes true. And now we need to check the second and. So now we've got true and is A greater than 0, which it is. So now we've got true and true. So now this whole thing evaluates to true. So we are good there. Now we need to check now we need to check our ors. And again, we need to check them from left to right. So we should check this one first. Is 2 less than 1? Of course it's not. This is going to become false. But we do have false or true. So that means this entire thing is going to become true. And now we're left with true or is 3 greater than 1, which it is. Now we've got true or true. And it really doesn't matter, just because this first one is true, it really didn't matter whether or not this was true or false. The entire thing evaluates to true. So that whole concept of precedence and order of operations comes back from Unit 1, and now becomes a little bit more complex. So the other thing to note is that if we have an exclamation point anywhere, that is a not condition, and nots always get evaluated before anything else. So again, we would need to look at these conditions and say, all right, well, we've got not is A less than or equal to B. All right, well, A is 1. That's definitely less than or equal to B. So this would become true. However, not true is going to become false. And so you would have false and then is B less than C. Well, that's true, but it doesn't matter. This would now become false because you would have false and true. Down here, before you evaluate the or, you have to get rid of this exclamation point. So is B is 2 less than 3? It is, so this is true. However, not true means false. So this would now become false. And is 2 less than 1? That's false. So you would end up with false or false. So the entire thing would evaluate to false. And then finally down here, we have this extra set of parentheses inside. So again, we're looking at a condition A or condition B, but our condition B is this entire thing right here wrapped in this parentheses. So we have to get rid of this exclamation point first. So now we have to evaluate what's on the inside. 2 is greater than 0 and 2 is greater than 1. So this evaluates to true, but then we have to flip it to false because that exclamation point is right here. So now you would have is 0 greater than B. This is false. And then you would have an or false. So this entire thing would evaluate to false. So we always have to look out for exclamation points because the not is always evaluated before anything else. All right, well, it's time for our lesson review. Let's go ahead and check it out. A multi-way selection is written when there are a series of conditions with different statements for each condition, and exactly one section of code is executed based on the first condition that evaluates to true. So we're looking at all of those if, else if, else if, else if statements. As soon as one becomes true, that only that one section gets executed. We have logical operators such as the exclamation point for not, and for and then the 2 lines for or. And those can be used with Boolean values and Boolean expressions. A and B is true if both condition A and condition B are true. A or B is true if either A or B or both are true. And then not A is true if A is false. And then conversely, not A is false if A is true. In Java, the exclamation point or not has precedence, is executed before the ands, which also has precedence over the ors. Parentheses can be used to force the order of execution in a different way. But just know that if you have any of those long Boolean conditions, compound Boolean conditions, remember to look for any nots, and if there aren't any nots, execute the ands next from left to right, and then after that, execute the ors. All right, guys, that's it. We've now taken care of lessons 4 and 5. Be sure to leave a question or a comment on our video, and I'll see you in class.